Hello, I'm Kevin.
I'm Scott.
I'm Allison.
And we are the French Toast Mafia, and today we're explaining our renewable energy planning and design tool.
Okay, so first of all, this project's going to help engineers and architects develop renewable energy systems for a small area. So the first task, we had to choose 3 cities here. We decided on Boston, Honolulu, and Los Angeles. And the reason we chose these 3 were, first of all, Boston has a relatively low solar energy output, so we could use that to compare to the other 2, which had other relatively high solar output. Honolulu and Los Angeles are pretty similar as solar output goes. Los Angeles has a pretty greater area, so we wanted to have those fluctuations so we could see different deviations between the 2. See here that we have the grid on top of the city of Boston, and we chose a square area of 6,400 feet per grid square. And we chose that because we figured that was going to be realistically able to fit our solar panels and wind turbines in. So like I said, each grid square contains 6,400 feet, and we did all the math to make each panel or each turbine fit and how many turbines or panels could fit in those grid squares. Once the size was decided, we scaled all the pictures to the same size for simplicity. And we decided on the smaller grid size because it allows for high customization from the user versus a bigger grid square, where it would be a larger area and much more panels or turbines per grid square.
Right now I'm going to go ahead and do a quick run through of the program. So on the left we have our workspace opened up, and for a first time user what they're going to want to do is open the file project2 rice dyer dumbler. So go ahead and click on that file and this script comes up, and if we run that we get the choice at what city we want to select. So for now we'll go ahead and select Honolulu, and we'll notice that our GUI comes up, and from here we can choose whether we want a solar panel or a wind turbine, what company and what model we want. So say I wanted a WindMax HY 1005, I would go ahead and click that and put that corresponding wind turbine on our grid. Also we have our functions at the bottom. We have an undo function and a clear all function. So if you watch where I put this, I'll put it in the upper right hand corner. And then I hit my undo function and it erases that point. Also the clear all function, if we click that, it closes our GUI, clears all previously created variables, and from there we have a blank slate. So moving forward, if we have different points on here, and I'll try to make some obvious ones that we can look at later. We also have our save to reload function. So what that does is we click that, it closes our file, and we see now we've created these 3 files, saved, save.fig, and save.m. So to open these, what you'd want to do is go back to the original script, run it, and hit load previous file. Now we can see that our previous points loaded on our grid space, and we can also continue to place points on this grid after it reloaded. Now I'm going to demonstrate how our Create Bill of Materials tab works. So I've already selected all these points on the grid, and then we go to Create Bill of Materials. And we'll notice that our Honolulu _ Bill of Materials text file has been created. And in this we see our file is organized by panels and turbines, quantity, and total cost. And at the bottom we have a summation for everything you have selected. Also as an option we've created our Save to Picture tab. So if we click this, we now have a picture called Honolulu Pic that can be opened in our Finder. And I opened that in preview and we can see that it has the picture of where our solar panels and wind turbines were placed. Here's a demonstration of the Save as Text output function. So we'll click on that for a Honolulu GUI. and we'll see our honolulu.txt.
So once the user loads their text file, then they get this file that says what the type of panel they were, that they placed, what row it's located in, and what column it's in.
So getting into the while loop that we created that works for the grid, basically we use the g-input function, and what this does is it it finds out where you are on the picture when you click, and it gives you an xy coordinate. And then we have our if function, and the condition is that you click somewhere inside the grid. And then I created this function, which is x equals 5 times the floor value of x divided by 5. And essentially what that does is it takes the grid, and it puts you in the upper left-hand corner of each grid space. And from there we use that on the fill function, so it fills the corresponding 5 pixels around that upper left-hand pixel in each grid space.
Also, since one of the required tasks was to create a solar energy estimate, but it wasn't listed as a separate save output, we just created the solar energy estimate each time for the user, no matter how they decided to save their file. So this is the text file that's outputted, and it's very simple. It just says in kilowatts how much solar energy was can be created in that city based on the number of panels and the type of panels that the user decided to place. So here's our code for creating the solar energy estimate. So first we have a vector that says how many panels we're able to fit in a square of our grid, and there's a vector created because the number is different for each type of panel. And the second vector is the power that can be produced in Boston per panel. So if we just multiply our global variable A, which is the number of panels we produced, or that we placed, by the power in Boston, which we got from our first project, and then times the number of panels that fit in the square, then it gave us the corresponding energy value in kilowatts, and we added that up for each type of panel so that we got a sum for all the panels. And then we just created this to a new text file. And we put this code at the bottom of all of our save functions so that the solar energy estimate is created anytime the user saves their program.
Every time you click, whether it's a text file or a fig file, what we did is we made sure that if a previous text file or a previous picture or anything like that already exists, that it goes through and goes ahead and deletes that. So for example, this is underneath our bill of materials, and if a bill of materials already exists, then it goes ahead and deletes that bill of materials so it can create a new bill of materials.